Hi class, for this example, or for this lab actually, I'm going to show you how to calculate the mean of a frequency distribution. And in this case, the assumptions that we have is that somebody already collected the data, they organized it, and they are providing a frequency distribution. So why would we want to do this? And this is because we may not have access to the original data. So the formulas that you see here are basically just estimators, and this is only used if you don't have the original raw data. Now, for any of these calculations, we're going to be using the calculator. So this is what I need you to do. Take a minute, and you technically have your your frequency distribution. So I need you to enter the lower class limit as your first column. That represents the 0, 200, 400, 600. That would be this column, and then the upper class limit as 199, 399, 599, and 799, and also the frequencies. Now, for the formula that we're using, we're assuming that we technically have a sample. So in this case, it's going to be this one. And for any of those two, x is understood. So x is equal to the midpoint of each class. So this is the midpoints that we evaluated as we did the frequency histograms. And I'm just going to label the x's. So if you're evaluating one of these, I do need you to tell me what you're punching in and which values you're obtaining. Let me show you how to actually evaluate these in the calculator. So this is how you're going to do the problems on that midterm. So what we want to do is that the software automatically selects L1 plus the L2, close the parentheses, and then divide that by 2. And if you happen to evaluate this inside of the L4, the calculation is going to be done automatically. So our midpoints are going to be 99.5. So in this case, 99.5, 299.5. So this is 299.5, followed by 499.5. So 499.5, and then the last one is 699.5. So 699.5. Now we need to create in this formula the numerator. So this is x and f. So we need to create another column where we multiply x and f. And some of these calculations are going to get very large. You just need to write down at least 2 decimal places. Now, for our calculator to actually evaluate this, your x's are L4. So technically, we went into L4. So this will be your L4. And then what you need is your frequencies. So your frequencies, we technically have them under L3. So this is your frequency. That is your midpoint. So what we want to do on L5 is basically say L3 times the value on L4. L3 represents the frequency, and this is your x's. So that's going to be creating the column where you technically multiply 33 times 99.5. So evaluate that on the calculator, and you have to make sure that you're clicking on the L5. No need of parentheses. I do have a typo though. This is supposed to be L4. Evaluate that. And some of these numbers are going to get very large because of the multiplications. So I'm getting 3283. So 32. And then 0.5. 26656. So 26656. The next value is 22,977. So 22,977. 14,690. So 14,690. 90. Let me double check that there's no error there. It looks like I'm copying everything correctly. So 3283.5. If your calculator is not giving you that 0.5, it's just what it's displaying, but it is carrying the correct values as long as you're matching with the rest of them, because it could have rounded just for displaying. Okay, so let's talk about the formula. So the formula on the top, it's going to use the sum of x times f. So in this case, that's going to be this sum. Now, you're not going to add it manually. We're going to use the shortcut. And for our shortcut, we're just going to get a one variable stats. So let me pull the calculator. But on L5, since technically that's what you have all of these. So this is your L5. So stats, run me a one variable stats, but we're talking about second and L5. Now, what the calculator is going to give us is the sum of the x's. So that is this value here, sum of the x's. So that column should add to 67,605. So 67,605.5. So 605.5. And then the last portion of the calculation is to actually obtain the mean. In this case, the mean of this particular one, it's going to be the actually, wait, we need the sum of the frequencies. So my apologies. We need the sum of the frequencies, which represents this sum. So the sum on L3. Let me just check that one value once more. 67,605.5. And now we need to get a one variable stats, but on L3. And the sum of the frequencies, I'm getting to be 189. So this is 189. So the mean of this frequency distribution, or the approximate mean, it's going to be 67,605.5 divided by 189. Please evaluate that and see if, and I'm obtaining approximately 300, whoops, it's 357.701. That is technically the approximate mean of the raw data. All of these are estimates, and if you're following the book, they're going to do other calculations where there's a different way to calculate the midpoints. This will be our next lab. But at this point, I'm getting 357. This is actually a 5. So for this assignment, what I need you to do is work on example 2, but you're going to assume it's a population. So all the calculations are going to be very similar, except that you're just going to call this one, well, mu, as opposed to x bar.